So for example, so this is still 2, 7 inverse functions. And we did a simple example of finding an inverse. So here's a harder example. Let's say we have f of x is equal to the cube root of 2x plus 7. 2x plus 7.
Oh, I thought everybody would be in here right at 10 o'clock on Friday.
So we want to find this function's inverse. Now, if I'm telling you to find the inverse, I am guaranteeing that it is a one-to-one function. But there is a question on the test that asks you to prove that this is a one-to-one function first, and then go and find its inverse. So let's prove it first, just for fun. Remember how to prove that it's a one-to-one function?
F of A equals F of B.
F of A equals F of B. And the goal is we're trying to get this down to just A equals plain old B. So what's F of A equal to? Your question of the day.
The cube root of 2x plus 7.
It is the cube root of something. F of A?
It's 2x plus 7, right?
F of A? I don't know how many times I have to say that. It's going to be 2A. Not 2x, 2A. So it would be 2A plus 7. And F of B would be?
2b plus 7.
2b plus 7 underneath the cube root. Alright? And then the general goal is solve for A. So what would be your first step?
You got F of A equals F of B. Cube root.
It's already cube rooted.
2a plus 7 equals 0.
Now, trying to solve for A, what do I need to get rid of?
Okay.
The radicals. How do I get rid of the radicals?
What? I can't see.
I figured you don't have your glasses on. It's like, does she have contacts in?
Nope.
So how do you get rid of a cube root? How do you get rid of a square root? Square it. How do you get rid of a cube root?
Cube root.
Cube it.
That's what I said a while ago. You said it's already cube.
No, you said cube root. Yeah. So you cube both sides, and you get 2a plus 7 is equal to 2b plus 7. Okay. And remember, we're solving for a. What would be your next step?
Subtract 7.
Subtract 7. You get 2a is equal to 2b. And then
Divide by 2.
divide by 2, and you get a equals b. Now, since a is directly equal to b, this thing is guaranteed to be 1 to 1. If it was a equals plus or minus b, or a equals the absolute value of b, then things just get bad and it's not 1 to 1
So basically,
function.
on the test, you are gonna have something like that, and this
It'll specifically say show by f of a equals f of b that it is a 1 to 1 function, and then turn around and find the inverse. All right. So we're going to turn around and find the inverse. So how do you find the inverse of this thing? What's your first step?
Let,
So you get y equals the cube root of 2x plus 7.
then you're gonna change x's to y's.
Change x's to y's and y's to x's. So you get x is equal to the cube root of 2y plus 7.
And we're gonna solve for this new y.
So how do you do it?
Cube.
Cube both sides.
Right.
So if we cube this side, the cube root goes away. When we cube this side, we just get a plain old x cubed. So this becomes x cubed is equal to
2y plus 7.
2y plus 7. Seems like someone's waking up finally. And then solve for y. So we're going to subtract 7 and divide by 2. So we're finally going to get down to y equals x cubed minus 7 all divided by 2. Because we're going to subtract 7 and divide by 2. Alright. If you leave your answer like this, you lose a point. Because the last step is to say, the problem here is you have a y equals here, and you have this y equals up here. They are not the same. They're totally different. This is of f of x. So this one must be,
The inverse.
so you have to write it as f inverse of x is equal to x cubed minus 7 all divided by 2. And the only reason you need to do that is so you don't get confused between the two y's, because they are totally different. One is the original function, the other one is the inverse function. And that's it. That's all you have to do to find the inverse of a function. Yay!
I came in here rushing thinking we could take a quiz today.
You couldn't even be on time when I passed you in the hall. That's sad.
They asked me to clean some stuff up.
Did you throw up or something? Okay, how about this one then? Trick question.
Okay, well it's not, you can't find the inverse.
Ooh, but I can if I play a little game. So we're going to play the little game and see what happens. And this becomes handy for a lot of functions, so you can talk about them being inverses. Because we kind of treat x squared and square root of x as inverses of each other. We kind of do, and we just have to be cautious how we do it.
But
So-
if a function is not 1 to 1, it can't have an inverse, right?
Not over the entire domain. Remember, I was really clear about that on Wednesday. Not over the entire domain. So if we do a little sketch of x squared, what does x squared look like?
Is that the parabola?
It's a parabola. It starts at the origin, kind of goes up in this direction, kind of goes up in that direction. And just by the picture, we know that this function is not 1 to 1. But I can kind of dissect the picture and talk about a restrictive domain. It's called a restrictive domain. We're going to force the domain not to be all real numbers. We're going to shorten it up so that we can talk about a one-to-one function. So we can talk about a portion of this graph that is one-to-one for a certain part of the domain. So where does the domain have to split for this thing to contain in all the range? The range is from 0 to infinity, but also be one-to-one. Where should I split it? Has to contain the entire range. Let me put it to a different point. Do I need both arrows pointing up to go off to infinity?
No.
I just need one. So if I cut one down, how far do I have to cut like the left branch down to get the entire domain, the entire range, but also be one-to-one? All the way down to the origin. So if I just look at this part of the graph, is this function one-to-one? Well, yeah. And the restrictive domain on this thing would be from 0 to infinity. In other words, all the values of x that happen to be positive. For this function, there is an inverse. But I have to make sure that the domain is from 0 to infinity. By the way, what's the range of this function?
The range.
The range, yeah. The green. What's the range of the green function?
0,
0 to
positive infinity.
positive infinity. 0 to infinity. Now, if I keep that in mind, then I can go through the process of finding the inverse of this function. So the first step is y equals x squared. The second step is
Change x and y.
change the x's and y's around, and you get x equals
Y squared.
y squared, and solve for y.
Square root.
Square root both sides. Now here we have to be careful. It's going to become y equals plus or minus the square root of x. Because if you square root both sides of an equation, you get a plus and a minus. Now, this comes back to over here. How do you find the inverse of a function? What's the main step of it? The main thrust of an inverse.
You're switching them x's and y's.
You're switching the domain and range. So this function has to have a domain. This is the inverse function. It has to have a domain that happened to be the range. But that is 0 to infinity. And it has to have a range that used to be the domain. So this would have also a 0 to infinity. In other words, your x's are positive guaranteed, so are your y's. So the one we're going to choose for this inverse is going to be G inverse of x in such a way that our range is positive square root of x. Sounds weird, doesn't it?
Yeah, that one is weird.
But that's how we use the inverse property of x squared and square root. We actually use that setup where x's are always positive.
I still don't really understand that because yeah, it won't. That one is not 1 and 1 like you said.
What is it? The green graph is 1 to 1.
The one where you got y equals plus or minus, you got plus or
Oh,
minus
no.
square root of x.
That's the thing, it's not 1 to 1.
Yeah.
So what you have to do is you go, oh, the range is positive, so the answer here has to be positive, so you just choose the positive root. There are cases where you do choose the negative root. So let's talk about that one next. That's not the only restriction I can make on the domain. If I come back to, x squared, the graph, it looks something like this. What if I chose the other branch? The one that starts here and goes to the left. What's the domain of this function?
0 to negative infinity.
No, well, you don't write it that way.
I mean negative infinity.
Negative infinity to
0.
0. And what's the range? Domain is that way. Which way is the range going?
Now I'm thinking y values.
What's
It's
the
coming from
lowest?
negative infinity.
No, well, it does not go down to negative infinity. 0 off to arrows pointing up. Positive infinity. All right, so when we find its inverse, its domain is going to be
0.
0 to infinity because it was the range up here. And its range is going to be negative infinity to 0. Because the domain and range just flip. Okay. So when I go through and I solve, I start off with y equals x squared, and I'm trying to find the inverse. You switch the x's and the y's. You square root both sides, and you get y equals plus or minus the square root of x. I mean, it's the same process as over here, except for one thing. Over here, x's and y's were both positive. Over here, x's are positive because you really need them to be positive because square root of a negative doesn't help us. But the y's here are negative. So instead of the plus part, we're going to take the negative part. So this becomes g inverse of x is equal to negative square root of x. So if we choose our domain to be positive x values, we end up with a positive square root. If we choose our x values in an original function to be negative, then our answer has to be negative. It's kind of a weird way of looking at it. And there's a lot of functions where we do this so that we can talk about an inverse and be able to calculate some things, and then we worry about what the sign of it is going to be, if it's going to be positive or if it's going to be negative. So that's called a restrictive domain. All right, let's talk about graphing functions. Graphing an inverse. We'll start off with one of these. Let's say we're talking about the restrictive domain parabola. And I want to graph its inverse. The best way to graph the inverse of a graph is to plot points. Imagine some points on it. So we already have one. This point here, 0, 0. Make up a point for this one. What would be reasonable?
Which one? Maybe 2, 1.
2, 1? Sure.
4.
All right, how about this one up here?
3, 5.
3, 5. That sounds good. So you just have to make up some coordinates so that you can just graph this thing the way it's supposed to look. Now, what is the main thrust of finding inverses? You take the domain and range and
Flip 'em.
flip it. So you take each one of these coordinates and you flip it. So 0, 0 becomes, well, 0, 0, that's boring. 2, 1 becomes
1, 2.
1, 2, so it would be up here someplace. And 3, 5 becomes
5, 3.
5, 3, which is over here someplace. So your graph looks like this. So the green graph, where the black graph, let's say, is f of x, the green graph would be f inverse of x. Are you ready? The restrictive domain graph I had is the black one. And the answer for it was the square root of x. What's the graph of square root of x look like? It looks like the green one. So they're inverse functions of each other. And the technique is, what really has to happen, and you have to look for this, is there's a line that goes right down the middle of these two. And the line's equation is y equals x. This graph has to reflect over this line, y equals x. It has to look like a mirror image. So the best way to do that is to take your paper, rotate it 45 degrees to the left, have this line become vertical, and it should be a mirror image over that dotted line. You all know what I mean by mirror image, right? Yeah. Like if you have this shape on one side, and I have, oh, here's your mirror, what's the shape on the other side going to be?
The same shape.
The same shape, just in
another direction.
Another direction. So your picture should look like this. Your original graph should be on one side, the other graph on the other, and it flips over completely. So let's do an uglier one. Let's start down here. For this to work, I mean, technically, just to be a one-to-one function, you have two choices. You're always increasing or you're always decreasing, because once you switch over from increasing to decreasing, you're going to fail that horizontal line test. All right, so let's come up with some reasonable points. Let's call this g of x. G of x. Let's come up with some reasonable points so we can invert it. So what do you think this coordinate is down here?
Is it 1, -4, or 2?
Try it again. -1.
I mean, yeah, -1.
It's always to the left. So -1, -4. If this is -1, -4, what's a reasonable one for this? 2, -2? Sure, that'll work. This one up here?
Maybe 3, 3.
Well, if this is 2 down, I would say 3, 5.
Yeah.
3, 5. And then this one over here? If this is 2, that'd be about 6.
6.
6, 6. Alright, and now I want to find an inverse. So what do I plot?
-4,
I take -1, -4 and make it
-4,
-4, -1, which is someplace, let me get the measurements right here. Right about there. It is right about here. So this would be -4, -1. 2, -2 becomes?
-2.
-2, 2, it's someplace up here. This 3, 5 becomes?
5, 3.
5, 3, it's someplace over here. The nice thing is on the test you'll have graph paper and you'll be able to plot them somewhat precisely. 6, 6 of course becomes? 6, 6, it doesn't move at all. So your graph would be this. And you can kind of imagine if there's a line going right down the middle of them at a 45-degree angle, it's somewhat a reflection. Of course, this is a sketch. It's not going to be perfect, but it's pretty close. So that's how you graph an inverse function. The domain becomes the range becomes the domain. That's all you really need to know about inverses. All right. Leave that up there for a second. Make sure I've covered everything.
This is what, 2, 6 there?
Last section.
And still 2, 6?
Oh, this is
2-7.
2-7. Now we're on to 2-8. 2-8 out of all of the sections in this chapter is the easiest. Distance midpoint, and circles. Ah, shoot. I screwed up already. Distance, midpoints, and circles. Today we'll probably, well, I probably could cover all of them. How much time do I got? Oh, yeah, I got time. After I teach this section, you'll be ready to do that extra credit project, which is on my webpage. It says, extra credit project module 3. Just click on it. It's, I think, a 15-minute video. That's how long it takes for me to explain what I want out of you. And then you just get to choose any 3 points that you want in the plane, and you'll understand it after you watch the video. But you do need knowledge from this part, the distance, midpoint, and the circle. You also need to know equations of lines. You also need to know parallel and perpendicular and how to find the equation of these lines. And there's one piece in there that you don't know how to do, and it's real easy, and most people get it. It's called a system of equations. All right, so let's start with distance. When we're talking about distance, actually, ignore that line. When we're talking about distance at the beginning of the year, it's first or second class, really at the beginning of the year. How do you find the distance between A and B? Subtract A from B. What if they're both negative? What if A is bigger than B or B is bigger than A? Because the order really doesn't matter. So you're going to subtract them. I'll agree with you there. But then you have a possibility of your answer being positive and or negative. So how do I force it always to be positive?
Absolute value.
Absolute value. So the distance between A and B is equal to the difference of A and B's absolute value. The absolute value of their difference. All right, we need that little piece so we can do this. In a plane, given any two coordinates, let's call this one x1, y1. Let's call this one up here x2, y2. No, I do not want to find the slope of it. So don't get confused between slope and what I'm going to do today. I want to find the length of this line segment, the distance between these 2 points. Okay. Now I've said a few times that there is no side-to-side motion in a piece of graph paper. There's only left, right, and up, down. So what I need you to do is to put a horizontal line through x1, y1, and a vertical line through x2, y2. And what that does is it creates this nice little shape here. What shape is that? I'll give you it's a triangle. It's a right triangle. It's much more important. So this is a right angle. Now, can I find the distance along the base of this right triangle? How? Do what with them? Find the absolute value of their difference. So the absolute value, and it doesn't matter what order you do it in. The book does x2 minus x1, but that's irrelevant because you don't even know where these points are to begin with. And then how do you find the distance of the height over here? The altitude. So you take the absolute value of y1 minus y2. Yuck. What? You're going along the horizontal. Your only thing that's changing is your x-coordinates, so you take the absolute value of the difference of the x-coordinates. The vertical motion only changes your y-coordinates, so you take the absolute value of their difference. I have a problem with that notation already. It's too windy. What's another way of writing x1 minus x2? Change of x. So I can rewrite this as the absolute value of the change in x, because it technically doesn't matter if you do them one way or the other, because eventually you're going to take the absolute value of them. So having the order wrong in this case, unlike slope, really doesn't matter. So I can call change in y, I'm sorry, I can already give you the answer. The absolute value of the difference of the y's is the absolute value of the change in y. Now I'm not talking about slope here, I'm talking about distances. All right, next little piece.
That's distance.
The absolute value of the delta y and delta x, yeah, that's distance. If I make it a ratio, delta y over delta x, that's slope. But if I keep them separate, they're just distance.
So that was the answer.
No, I'm not done yet.
I'm not saying.
I haven't even gotten close to D up here. Now, if I have a right triangle, and I know three of the sides, A, B, and C, and I know two of them, I'm sorry. If I know two of the sides, I don't care which two I know, can I find the third side?
Pythagorean theorem.
Pythagorean theorem. Pythagorean theorem, the way I write it, is c squared equals a squared plus b squared.
A squared equals b squared plus c squared.
Why do you think I put c first?
Because that's what you're looking at.
No. What does c represent?
The long side.
Which is called?
Hypotenuse.
The hypotenuse. It's more important than the A and B. The A and B are just legs. So if you get the important side straight, you're pretty fine with everything else. In this right triangle, what's C equal to?
We don't know.
Yes, you do. What's it called?
D.
D. So I'm going to replace that with D squared is equal to, what's A in this case? Change of x, the absolute value of the change in x, all squared. The absolute value of the change of x, all squared.
Hold on, why was that? Oh, okay, good. Continue.
Okay. Thank you. Plus, and then B gets replaced with
Change in y.
the absolute value of the change in y squared. I like the change in x and change in y because it reduces how much I have to write, but it still tells me what I need to know. That I subtract the x's and subtract the y's. Now, when you look at the absolute value of the change in x all squared, what does the absolute value do to any number?
Make it positive.
Makes it positive. What's the square do to anything? It squares it, but it also makes it
Positive.
positive, guaranteed. So I'm making this thing positive twice, but I only need to make it positive.
Once.
Which one can I get rid of without changing the answer?
No, absolutely.
The absolute value. If I remove the absolute values, my answer is going to stay exactly the same. So I can rewrite this as d squared is equal to the change in x all squared plus the change in y all squared. If you need, you can put parentheses here. It won't hurt anything. Okay. And I just want to solve for d. So d, if I want to get it by itself, is equal to the square root of the change in x squared plus the change in y squared. Trick question. Can I write this as delta x plus delta y? Can I reduce this to delta x plus delta y?
No, because it's on the radical.
More important than that,
They got that plus in the
there's a
middle.
plus sign in between them. You can't simplify over pluses and minuses. This is the distance formula. Now, you can either use this as your distance formula, you can use the parentheses x2 minus x1 all squared plus parentheses y2 minus y1 all squared, but it gets kind of confusing. Delta x just means subtract the x's, delta y means subtract the y's. So for example, if I want to find the distance between -3, 8, and 4, -5. One of my test questions, it says find the distance, the slope, and the midpoint of a line segment. The easiest way to answer it is to come over here and say, well, what's delta x equal to? Just delta x by itself. What is it equal to? You would say -3 minus 4 is -7. And what's delta y equal to?
13.
Yeah, it would be 8 minus a -5, better known as 13. Now, if you want to find slope, what's the slope of this line segment? Careful. Slope is change in y over change in x, which is -13 over 7. You have to get the order of it right. Now, there's a big difference between using delta y and delta x over here and delta y over delta x over here. Here, these are distances you do not want to reduce. Here, if there was any reduction to be done, like if it was 4 halves or 8 twelfths, you'd have to reduce it. But don't reduce these numbers over here. These are not fractions. These are individual answers. All right, now if I want to find the distance, well, I just tuck it into the formula. something squared plus something squared all underneath the square root. What goes in the first parentheses?
-7.
-7. What goes in the second one?
13.
And guess what? If you screw up the order, does it change the answer? No. So unlike slope, this one, order is nowhere anywhere around here. Just make sure it's x's with x's and y's with y's. And then we get distance is equal to the square root of 49 plus 169. I don't know, what is that? You all have calculators.
49 plus 169.
This is 49 plus 169.
219.
What is it?
219.
219. 218. 218. Now,
Yep.
should I leave the square root of 218 on my paper?
No.
You best test to see if it reduces. It's even, so 2 goes into it. How many times?
109.
109. I can't think of any number that goes into 109, can you?
3 doesn't?
3 does not because 1 plus 9 is 10. 9 doesn't because 1 plus 9 is 10. 11 probably doesn't go into it. 13, I doubt it. So I'm guaranteeing you that 109 is pretty much not going to break up. And if it does break up, you're not going to get 2 of them. So your answer is square root of 218, which is approximately, brain not working right now. What's square root of 218 close to? It's bigger.
About 14.
14.
Almost 14.76.
15 squared is 225. Alright. So that's the distance formula. Real easy. Most people get it right. Just be careful that you do not reduce your change in y and change in x. You should be fine. The next topic is not so nice. Midpoint. Let's talk about this again. Here's A, here's B. And by geometry, given any line segment of any length, you can always find the midpoint. So this must have a midpoint on it. Let's call it M. What's true about midpoints?
The two sides are equal.
The two sides are equal. By geometry standards, you would say, call this A, B, M. Then you'd say AM is equal to, or congruent if you want to be really fancy, to MB. If M is a midpoint, then the two line segments are congruent to each other. Remember geometry?
She talking about that symbol you we ain't seen.
Congruent, yeah, I gotta love it. We're going to be doing a lot of geometry with this problem, so give me a second. If you want to do little marks, the marks were, the little dashes, and you'd say they were congruent by those little dashes. So how do you find the midpoint between two numbers? People are funny. Add them together, divide by 2. If you wanted to average your test scores, you take 2 test scores, you add them together, and you divide by 2, and that's the middle. So to find the midpoint here, you'd go A plus B divided by 2. A plus B divided by 2. This has to equal the coordinate for M. Has to equal the coordinate for M. Okay. So let's take it away from a one-dimensional object and put it into 2 dimensions. And by the way, the process really doesn't change too much from dimension to dimension. Same thing with distance formula. If I added on a 3rd dimension, this formula wouldn't change very much, which is kind of cool if you think about it. Okay, give me 2 points. So here is x1, y1. Up here someplace is x2, y2. And I want to find the midpoint, which is right about here. We'll call this M of this line segment. Now I know M exists, I just don't know the coordinates of this point. Geometry just says it exists. So the only thing I can do is create a bunch of horizontal and vertical lines and see what happens. So I'm going to put a horizontal line through each one of these points and a vertical line through just one of them. Well, actually, through 2 of them. I'm going to put a vertical line here and a vertical line here. Make them solid, why not? Now, what I'm looking for here is this triangle, little baby one on the bottom here. That's also, it's a right triangle. And this triangle up here. And that's also a right triangle. Okay. What do I know about this picture? Well, I'm already saying that M is at the midpoint because I know it does exist someplace in the plane. If M is the midpoint, what is true? Let's call this one A, let's call this one B. What's true about AM and MB?
AM is equal to MB.
Oh, come on, say the fancy word.
Congruent.
Congruent. Yay. So AM is congruent to MB, so I can put these little dashes in here, indicating that they are equal to each other. What else do I know? Let's see. I know they both have a right angle. Okay. And that's about it right now.
You know that we find hypotenuse and midpoint have a
Does a right angle and a hypotenuse guarantee congruent triangles? Yeah. So I need a little bit more. So what I need to do is go down here someplace and look at this line segment. This is not a true proof, but this is just kind of this is where we're going. Can I find the midpoint of this line segment?
Should be.
Sure, where is it?
In the middle.
Well, what's the x-coordinate here?
1, 0. What point?
Right here. What's the x-coordinate of this point right here?
1, 0.
Okay, what's the coordinate of this point?
1,
X,
3,
1, Y.
whatever.
x1, y1. What's the x-coordinate here?
Okay, X1.
x1. Phew, pulling teeth. What's the x-coordinate of this one over here? x2. Because it's directly below that point, and it has an x-coordinate of x2. How do I find the midpoint of this line segment?
It's
Add them together and divide by 2. So the coordinate of this value, smack dab in the middle, is x1 plus x2 all divided by 2. Well, if I bring this up, that goes all the way to the top. It goes to n. I just have to prove something about it. Actually, I shouldn't have said the hypotenuses are equal to each other. We'll ignore that for a second. All right, what about this line segment here? What's its midpoint? Well, the bottom y coordinate is y2, bottom one? Bottom one,
Yeah, Y1.
y1. The top one is
Y2.
y2. And in between it, to find the midpoint, we would do y1 plus
Y2.
y2 all divided by 2. And that would go all the way over to there.
I wasn't even. What did you just do?
Which part? The y1, y2? This part of the triangle has a low point of y1 because it's directly across from the y1 point. See? Y1.
Okay.
And the top part of it is at y2 because heights are determined by y values. So if it's y1 at the bottom and y2 at the top, the midpoint would be y1 plus y2 divided by 2. Now, even without knowing that these two line segments are congruent, what we have is the base of this first triangle here is congruent to the base of this triangle here. Why?
Is it because do the right triangle got something to do with it?
No. This segment is equal to this segment on the base, right? That forces this segment to be equal to this segment. What shape is this thing here? That is not a square. It's a rectangle, and opposite sides of a rectangle are equal. So we get this piece is equal to this piece. So that guarantees me that these two triangles are congruent, forcing all the sides to be equal to each other. The bottom of these are equal, the sides are equal, and the hypotenuses are equal. So that forces the coordinate of M, in a roundabout way, to be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. I hate formulas. I find them useless. The easy way to remember this is to find the midpoint between two coordinates. You average the x's and you average the y's. That's all you have to do. Average the x's. Oh, this stuff? Yeah, this is easy.
That's 2
I'm talking about,
tons,
like,
right?
Oh, no. That's just getting me to the formula.
Oh, yeah.
It's not going to be on
You
the
did
test.
again.
Yeah, I should put that on the test. See if you remember geometry.
No.
So, for example, if A is 4, -3, and B is -2, -7. I don't know. Just making them up. It might not come out pretty, but it'll work. Find midpoint of AB, of line segment AB. So to find the midpoint, don't even look at the formula. All you need to do is average the x's and average the y's. Ooh, biggest mistake I've ever seen here is I've had someone change that comma into an equals. What good will that do you? None, because we're looking for a coordinate. It has to have an x coordinate and a y coordinate. All right, so if I'm going to average the x's together, what am I adding?
4 plus -2.
Because if you're going to add, you're going to literally add. So it's going to be, average. You're going to add the 2 x coordinates and divide by 2. And then over here, you're going to average the y's. So you add your 2 y coordinates, which are -3 and -7. You're going to divide by 2. Do you see where mistakes will happen though? With midpoints, you're adding. With distances and slopes, you are subtracting. And distances also, you're subtract, but then in the middle, you're going to add. So a lot of signs you can screw up here. All right, 4 plus a -2 is 2. 2 divided by 2 is 1. -3 plus a -7 is -10 divided by 2. And this would be the coordinate of the midpoint. Not bad. It's actually kind of easy. So that leads us into the harder topic. The last hard topic. Which we barely have enough time just in this section. Circles. Circles fit in perfectly here. For a lot of different reasons. For instance, if you have a circle, what's the definition of a circle? Please, come on. How do I draw a perfect circle?
The radius.
It has something to do with the radius. How would you draw a perfect circle? Minus a shot glass.
Distance to work, something right.
Diameter.
A compass. What does a compass do?
It measures degrees.
I know, but no, it does
It
not
draws
measure
a circle
degrees. That's
for
a protractor.
It draws a circle for you.
You stab one end in,
And then keep going all
you
around.
extend out to your radius, and then you take it and you draw it all the way around. So 2 things are happening. You have a fixed point, known as the center, and you have a fixed radius, which is a distance. So it is all the points that are the same distance away from a given point.
Oh.
Stop saying radius.
Oh.
So the definition of a circle is all points equidistant from a given point. Can anybody tell me why this definition is not a circle? I'm missing a few words.
That could be an issue.
No. If I take a point here, and I find all the points equidistant from this given point right here, what shape do I get?
A sun.
A sun, a sphere. You'd get a sphere. So how do I force it to just be a circle? I need to put it in a... What's a plane? Dang it, I gave you the answer away. A plane. It has to be on a blackboard. It has to be a single surface. So all points equidistant from a given point in a plane. Because if you don't say that, it could be a sphere because you could be in space. All right. So it has the center. This is called the center. It has a radius. And as you rotate that radius around, you generate the circle. Now, the circle is the picture itself. You don't really draw the radius or the center. It's the circle itself that is the shape. There's other lines in a circle that have special names, like this one. If you go side to side right through the center, that's called a diameter. Oh, by the way, just for fun, this line segment here is called
Secant.
Chord. Chord. If I continue the line through the circle and it, goes into a line instead of a line segment, that's called a secant. And if I hit the circle exactly in one place with a line on the outside, this is called
Tangent.
tangent. Okay.
Oh.
Now, why do midpoints come in handy here? Well, if you have a diameter, what's at the midpoint?
Center.
The center. So if you know the length of a diameter to find the center, you just need to find the midpoint. That comes in handy. This also becomes in handy. If I need to find the radius, it's the distance between the center and any point that's on the edge of the circle. So the radius is the distance from the center to the circle itself. So that brings the distance formula into it. And let's see what happens. So if I put all of this in a coordinate plane, and I throw the center here, center, and I call this center h comma k. Yay, I have a point in the center of a circle. How many circles have that as the center? How many circles have that point as its center?
All
How many are there?
infinite.
An infinite number of them. But I want to talk about just one specific one. Let's give it a radius. And someplace out to here, let's call this r. And what happens is you're going to wrap this radius around and you're going to generate, not horrible, a circle. I mean, that's supposed to be a circle, but it's hard to draw. Only one person in history could draw a perfect circle.
On what?
Only one person that I know of could draw a perfect circle. He's the one that painted the Sistine Chapel. That's how he got the job. He painted a perfect circle and said, here, this is what I can do. They hired him. Okay, so I want to come up with the equation of this circle. And all I know about it is it has a center of HK, and I know the distance from there to any other point in the plane is r. So what you do is you say, oh, it hits the circle here at an infinite number of points. Well, if it's an infinite number of points, I better call it xy. So we're looking for the set of points that are r units away from HK. That's all we're looking for. We should be able to do this. R is a distance, isn't it? And it's the distance between HK and xy. So we can set it up as a distance formula. The distance is equal to the square root of the change in x squared plus the change in y squared.
Oh, we're trying to find the distance.
The definition of a circle is all the points that are distant from this point to this point. So I might as well just use the distance formula and see what happens. In this case, d is r, so I can replace it with r, square root of change in x values. What are the x values that I'm dealing with here?
H and X.
H and x, I'm going to write it as x minus h all squared plus change in y. Y minus k. Technically, it doesn't matter which order you put it in. This is standard, when you put the variable first and the number second. All squared. Now, to get it in the standard form of a circle, we're going to write it as x minus h all squared plus y minus k all squared is equal to r squared. We're going to square both sides of the equation. So here is the equation of a circle. Question number 1. Is this equation a function?
No.
No, why?
Vertical line.
Vertical line test is going to fail horribly. It's going to hit it twice almost everywhere. Okay. So if I tell you that we have an equation that looks like this. X squared plus y minus 4 squared is equal to 9. What is the center? And what is the radius? What is the center of this circle and what is the radius of this circle?
confused.
Now, the center up here is HK. Notice what's missing on H and K. They both do not have
Sorry.
a negative sign. This is like transformations. It goes opposite of what you think it's going to do because it's inside of parentheses. So this one it would move positive H, and this one would move positive K, depending on if H and K are positive. So what's H here? 0. There's no H, so it must be 0. What's K? 4. So the center is at 0, 4.
Hold on. How you know the zero?
Because there's no, I can write this as x minus 0 all squared. There's no number there, so if I wanted to put one in, it has to be by the identity, additive identity specifically. Now the radius, I'd highly suggest you do this. You take your 9 and you write it as r squared is equal to 9, therefore r is equal to 3. Why not plus or minus 3?
Because radius distance is always
Because
positive.
radiuses have to be positive. So my radius is r equals 3. Isn't this easy? Maybe we could have the test on Wednesday.
No.
About Tuesday, sure. If you want to come in, I'll have a class.
We have a 10 what?
Friday. It's really Friday. Next Friday.
Ah, we could do that, but I don't want
He's
to.
trying to knock it to wings.
I don't want
No, you
to.
not.
X plus 3 all squared plus y minus 2 all squared is equal to 5. Last one.
Okay, and with the center, you said if it's so like that's positive 3 and negative 2, it's really gonna be negative 3, positive 2.
So the center is at negative 3, positive 2.
Okay, so yeah, that's basically.
Transformations inside goes opposite directions. And the radius?
Is 5.
I highly suggest you go off to the side and say r squared is equal to 5. Therefore, r has to equal the square root of 5. That way you don't screw up on this thing. Because I've seen people say 25. I'll say 5 here and they'll say, oh, the radius is 25. They square it rather than square root it. So if you just go off to the side and say, well, this is r squared and it equals 5, then solve for r. So your radius is square root of 5. A little bit bigger than 2. A little bit bigger than 2. Oh, by the way, you can graph these things. It's just most people graph it horribly. Center is negative 3, 2. So you go 1, 2, 3, 1, 2. And you put your center point. How would you draw the rest of it, though? Assuming that the square root of 5 is approximately 2.
You would go about 2, just
Go
move
up 2,
move to the right 2.
right 2, left 2,
Right 2, right?
and down 2. Go in every direction 2 units. So you go up 2 units, you plot a point. You go right 2 units, you plot a point. A little bit bigger than 2. You go left 2 units, and you go down 2 units. And you try to draw a circle through those points. What do most people draw? Diamonds. Those are used in connecting the dots. But that's how you would draw a circle. You plot the center point and you just count up, left, right, down, whatever the radius is. That's what it means to be a circle. All right, homework.
None.
None.
Study for the test.
None.
You need to
You're going to have all week to study for the test, so don't worry about
not
that.
necessarily.
In 2.7, did I sign anything on page 280?
Yeah.
I don't feel like I did. No one ever asked me the questions about 81 through 84 and 89 through 92. So,
We're practicing next week.
You didn't.
Catch up first.
oh, catch up.
You did.
So in 2.7, all the checkpoints. Then on page 290, you should be able to do
90, you said?
290. You should be able to do 3 through 27 by 3s, 29 through 37 odd, 41 and 43. Oh, and 53 through 58. 53 through 58, and no, I did not say odds. Wait a minute, that's just 4, 7, or 2, 7.
I thought
2,
you
8,
finished.
2, 8, just do the checkpoints. The extra credit I'm gonna give more homework next class. The extra credit is due on test day. So you might wanna watch the video, see what the heck I'm talking about, and
This
then
Friday?
it's online. My extra credit project is online. You have to go to my webpage,
Yeah, so.
click on the thing that says not free extra credit.
You go ahead.